I think it's been a great day, and I know these are going to be a really brilliant way to finish us off as well. So first up, we've got Isabel, who knows a thing or two about the Aflac duck, and I, for one, am very excited about that. So give a big round of applause.
Hi, everyone. Can you hear me okay? Yep. Great. Thank you so much for coming, and thank you to Women Techmakers Belfast for having me today. Today, I'm here to talk to you about the Great Migration, navigating the highs and the lows of data platform migration. So to start, a bit about me. My name is Gregory. I'm an engineering manager at Aflac Northern Ireland. I am Welsh. I like to just get that in early before people assume that I'm English, and then it gets awkward. So yeah, I am Welsh. I'm big into sports. I'm usually playing rugby or watching rugby, and I'm currently in training for my first Ironman later this year. Oh, thanks. In terms of my career to date, so I did an integrated master's in maths at the University of Bath, and I graduated in 2018. I then moved over to Belfast to work in PwC as an investigative analyst, which is just a fancy name for a data analyst. I then went into a company called Diaceutics, which is a healthcare analytics company, also as a data analyst, before pivoting slightly into data engineering when I joined Aflac Northern Ireland. And I was promoted to a manager in 2023, also in Aflac Northern Ireland. So a little bit about Aflac, for those of you who don't know, and sorry, on this screen, the 69 looks really wrong, but on this screen looks good, so that's good. So Aflac is a 69-year-old insurance company, and they do supplemental health insurance. So what that means in the US is you have health insurance, which covers you for lots of things, but it doesn't necessarily cover you for everything that you need as a patient. So it might cover you for the hospital stay, but not for the ambulance that gets you to the hospital. And that's where Aflac comes in. They have over 50 million policyholders, and they've been on the Fortune Global 500 list for 10 years. There's also 90% brand recognition by US consumers. So the reason I'm telling you that is that in the US, Aflac is a pretty good, big company, pretty well known. But Aflac Northern Ireland only started in 2019. And the reason they started is because Aflac had, in previous history, had a lot of contractors doing the data and the security and the tech. And they really wanted to bring more of that in-house. So they set up Aflac Northern Ireland, kind of like a startup. There's about 170 of us now. And we purely work on the tech and the data and the security side of things. So all of these things, important things to know about Aflac. But really what you need to know, the most important thing, is that they really love the duck. I mean, they really love this duck. And the reason that they love this duck is, as I said, there's 90% brand recognition in Aflac in the US, so it's pretty high. But previously, that wasn't the case. Back in 1999, a lot of people struggled to remember the name Aflac. It wasn't particularly catchy. They couldn't really remember what it was. And so the marketing company was sat in Central Park, and they were like, how can we make this more catchy? Like, what does Aflac sound like? And they saw some ducks in the pond, and I can only imagine this is what they heard. Hopefully you can hear that at the back, but it's quacking Aflac very loudly. Now, apart from the fact that Aflac and quack both have the sound ack in it, I'm not really sure where they were going with that, but it worked. As you can see, the duck is everywhere, and Aflac is very much synonymous with it. So with that in mind, I'm going to now tell you about the Great Migration, and just as a good Aflac employee, bring the duck along with me. So first things first, did you know that ducks migrate? And they migrate to move to a better suited, safer environment for their longevity. And this is really where our migration came about. So just like the ducks, they need to migrate to move to that long-term safer environment. We needed to do that with our Aflac data. We needed to move it to a long-term safer environment as well. So to tell you a bit about what my team look after, we look after the system of truth. And what that means is that we have lots of different sources of data. I've got 5 on the board here, but there's actually a few more than that. And we take that data in, we manipulate it, we aggregate it, we transform it through ETL pipelines into shared domains of data. So we've got agents, policies, claims, financials, accounts, and customers. Those are our 6 shared domains. And hopefully, as an insurance company, most of those kind of make sense. The one you might not know is agents, and that's basically, in America, you can be an Aflac agent, which means you just go door to door and sell insurance. So that's the data about them. So we, as I said, we store this data, after it's been all put into those shared domains, and we create system APIs to be able to make that data available for our apps. Now, again, I've got 5 apps on the board there, but actually we've got a few more consumer apps in the company. And the reason I'm telling you that is because our consumers, and as I go through this and I say our consumers, I mean my team's consumers, which is actually other teams in Aflac. So it's teams who might create the app that goes out to customers, so they can log on and they can check their claims or they can check their policies. So this system of truth was set up, and it was set up historically by contractors, and we came on board and kind of took over it. And historically, the data was stored in DynamoDB, AWS DynamoDB. So that's the blue square that you can see on the board there. So we'd have a different table for each of those different shared domains. And then we'd also have for each of those shared domains an API. So I've also put the API in green on there. And most of this is going to be about data, but I will come back to APIs more so at the end. So the API is just going to serve that data from our DynamoDB table out to our consuming apps. So I just wanted to do a show of hands, always a bit scary in a room, so please contribute, as to who has either worked with or knows what DynamoDB is. Great, there's loads of people. Okay, cool, so about half the room. So for those of you who don't know what it is, Amazon DynamoDB is a serverless, NoSQL, fully managed key-value database. Let's break that down. Serverless means that there's no need to manage servers. Resources scale automatically based on the demand that you have for them. NoSQL is, as it sounds, there's no SQL involved. When I was a data analyst, we would have used a lot of SQL and a lot of relational databases. This is kind of the opposite of that. So, there's no SQL involved. You're using a non-relational database, and you've got the data in key value pairs. So key value pairs is like a JSON workload with different key values all the way down for that one record. And then fully managed means that AWS handles the maintenance, the scaling, the backups, and the security for you. So in terms of positives, it's very performant and scalable. DynamoDB offers seamless horizontal scaling. It's relatively cost effective, which obviously a business always wants. And it's got this serverless architecture, which means it's easier to deploy and maintain. So to me, that sounds pretty good. And why migrate? Because just like this poor duck, the environment was no longer suitable for our needs. So we had one really big challenge with DynamoDB, and that is that the maximum item size is 400 kilobytes, which is not particularly big. That has to hold all of the values and all of the kind of column names as well. So if we go to a specific example of the claims domain, our consumer apps require a lot of data about claims to be able to function. And what that meant in the back end is that for a single claim, you would have a master record in the master claims table, which would just hold like the kind of keys about the claim. And then you'd have 4 records in the claims table under claims, details, payments, and remarks. And that was the only way that we could get all the data in about a claim. So that means that we had a minimum of 5 records for one claim in DynamoDB. Now, just to add another layer of complexity, claims can have up to 12 sheets. And my poor understanding of what a claim sheet is if you have a policy and you are going to file a claim under a certain benefit, so maybe it's a hospital benefit because you went to hospital, but maybe it was also an accident and you also have an accident benefit, you could have a claim with 2 sheets. That would count as 2 sheets, okay? So one claim can have up to 12 sheets. So what that means is if you don't have 5 records in DynamoDB, but we actually, if anyone wants to count all of them, we're going to have up to 49 records in DynamoDB for one claim. Now, not only is that really inefficient, it's really difficult for us to be able to go through and analyze that data as well. So what that might mean is one of our consumer apps might come to us and say, one of these payments looks dodgy, like one of these payments is wrong on this claim. We might have to look through up to 49 different records in DynamoDB just to be able to find where that payment was wrong. DynamoDB was no longer a suitable environment for us. So what we needed was we needed more space. We wanted better tools for analysis. We now wanted to have autonomy over our security and setup. We didn't want it to be fully managed by AWS. And we needed to have at least the same speed, if not faster, because DynamoDB is pretty speedy. So we still wanted to maintain that. So we got DocumentDB. And this is a document database service designed for JSON-based workloads, which is the workloads that we have, offering MongoDB compatibility, automatic scaling, and high availability. So all the good buzzwords. So in terms of what we needed, we needed more space, and we got a maximum document size of 16 megabytes, which is much, much more availability for our records. We also wanted better tools for analysis, and DocumentDB enables complex data processing, and that's directly within the database. So if you use DocumentDB, you can use a Mongo shell, which is what we would use, and then you can write a query, which is kind of similar to SQL, and you'll be able to get that data back really quickly. It's also customer managed, which means that we could implement our own best practices through subnets, security groups, create and read replicas in different availability zones, and use a secret manager for credentials. And finally, we actually got faster speeds. We got a response time reduction of 90%. And some of that is due to our code being way better, which I'll come into in a second. But part of that is because DocumentDB is very well set up for that. So if we look at our claims domain, in DynamoDB, we had a single claim having up to 49 records. In DocumentDB, all of that data could be put in one claim. All of the data for the claim can be put in one record. And again, comparing the two, in terms of DynamoDB, we would have 2 tables. In DocumentDB, that was just 1 table. In DynamoDB, we'd have that up to 49 records per claim, and in DocumentDB, only 1 record per claim. And that actually equaled out to being a massive reduction from 278 million production records down to 75 million production records. And so in terms of the benefits that you get from that, you get reduced latency, improved performance. Obviously, it was a much more simple design because you had 1 record per claim rather than 49, and a reduction in cost. So we knew this was the way to go. And we really thought that our migration was going to be like this, a beautiful blue sky, and we were just going to seamlessly change from DynamoDB to DocumentDB. We had all the ETL pipelines set up. It's just, quick change. But actually, our migration was more like this. We hit every storm, every fire, every rain cloud, and there was a lot of hurdles along the way. And actually, I think if I'd listened to Laura, I think it was who spoke earlier, I think if I'd listened to that before I did this project, maybe we would have been in a different state. But here we are, hindsight's a beautiful thing. So in terms of our hurdles, the first one was that legacy code. Again, I think Laura spoke about that earlier, on both the data side and the API side. So we had inherited code that was written a long, long while back, and it wasn't written particularly well, to put it politely. So we were going into this code and we were like, I have no idea what's going on. I have no idea why they did that way, that way. Really, really difficult to understand. The versions that were used in the code were also out of date. So I think Python, all of the Python files were 3.8 or lower, and all of the Java files were Java 8 or lower. There was no testing. Not a test in sight, not a unit test, not a regression test, definitely no automated tests really at all, but not even any manual tests, nothing to show that this code that they'd written actually worked and did what it was meant to do. Along with that, no documentation. So, if you're looking at claims data, for example, and you don't really know a lot about AFLAC or, American insurance, it's very, very difficult to write code if you don't understand what the data's doing. And I think, any data analyst or data engineer or anyone who works with data in the room would say that if you don't have context on what your data is doing, it's very, very difficult to write code to manipulate that data. All of the code was also in a monolithic repo. And what this means is that in GitHub, we had one repo that held every bit of code about all of the different sources, all of the different domains, everything, one code base. Now, I have 9 engineers on my team in AFLAC Northern Ireland, and there are about 10 engineers in our contracting pod who sit in India, and then we have a couple of engineers as well in the US. So we have 3 different time zones, over 20 engineers working on one code base, which has every piece of code for this massive database, just an absolute recipe for disaster. And lastly, consumer testing. This was something that we didn't have the awareness at the start that, because we thought it was going to be quite a simple, as I said, I thought it was going to be like blue skies and it was going to be quite simple to migrate this. We didn't really set up our consumers to test. We were kind of like, oh yeah, at some point you'll have to test this and it'll be really easy because it's going to be really easy for us. And that was not the case at all. So it ended up being a lot of time and effort for them, which we hadn't expected. So these hurdles really led to quite a lot of lows. And the first 4 hurdles that I mentioned there meant that we had a massive increase in the time taken. we thought we were going to do this kind of lift and shift, but that was no longer possible. We actually had to re-platform, and that meant that rewriting all of the code for the data, but also for all of our APIs, we had to make what we've called version 2s of our APIs, because we couldn't just switch everyone over straight away. We had to have two things running in parallel, so we made a version 2 of all of those 6 APIs. In terms of the monolithic repo, as I said, a lot of engineers, different time zones as well. So we had frequent merge conflicts, also security issues, because in GitHub, it's repo level security. So if you have one repo which everyone's working on, you're all going to have the same security, which was not particularly safe. And a very slow code base. If you've got a pipeline which has to run through all of that code that I've mentioned, it's going to run pretty slowly. And the consumer testing. Because we hadn't realized at the start that it was going to be quite the mountain of work that it was, there was a real breakdown in communication. And part of that was when you make code better, you do your best to change something for the better, you might not realize that has a butterfly effect down the line, that you've changed something. To one of our kind of most infamous issues from this migration project was we changed a empty response to a null response because the request was not bringing anything back. So we thought, well, then it's bringing back a null response. We should change it to a null response. But actually, the consumers down the other end were not ever checking for a null response. They were checking for the empty response. And so they ended up hitting a lot of 500s, which they hadn't hit previously. So this all kind of bubbled up to tensions from our team and with the consumers. And at times, it was really quite unpleasant. But you'll be glad to know it's not all doom and gloom, and these hurdles and lows did lead to opportunities. So in terms of having to re-platform rather than our lift and shift, we now have code which follows our best practices. We've rewritten everything, so the code follows our best practices, and we have clear testing plans, and also a lot of automated tests. So we have unit tests, regression tests, and where we can't do an automated test, we've put in a lot of manual testing and a lot of documentation to be able to show this is what we've done and this is why we did it. We've also upgraded our libraries, so Python, we're on Python 3.12 now, and Java, we're on Java 17. In terms of the monolithic repo, we took this as an opportunity to break down our repo into multiple repos following the same standards. This means that we have rarely any merge conflicts anymore, and the developer progress is a lot quicker. This kind of ended up being a side project alongside the project that we were already undergoing, and it was definitely a case of slowing down to speed up. It took a bit more time, but I think that we've now come out the other end, and things are so much quicker and so much easier to work with. And in terms of consumer testing, because we've gone through kind of all these difficulties and, as I said, the butterfly effect of changing things and realizing that it actually has an adverse effect at the other end, we now have a better awareness and understanding of what our data is used for. And I think that so do those teams, because they didn't actually know what they were using our data for either. And now we've had to speak with them about it a lot more and work a lot closer with them. We definitely have a better awareness and understanding both ways. We also have stronger relationships. Sometimes you have to have those difficult conversations to be able to come out the other side and say, okay, now we've got an open, honest kind of relationship where we can talk about anything. And it's also built some resilience. I think, not only in my team who really, we hadn't had anything like this before where we'd had people being unhappy with us, but also for myself, I'm very much a people pleaser. This was my first project as a manager. And when someone comes to you and says that doesn't work anymore and I'm angry with you, I took it very personally at the start. But I think that, as I went through and I had more of these conversations, I realized that, of course it's not personal. It's just that someone got a 500 when they got a 200 before. And now, they want to get back to getting that 200 and let's work together to make that work. So I think that we've definitely, as I said, got stronger relationships now, but actually, better resilience within the team. So we definitely learned a lot, and I wanted to kind of finish the last, I think it's 10 minutes here, just by giving you some takeaways that hopefully can help you if you end up having a project similar to this. So the first thing is how to break down a monolithic repository code base. If you are working on a monolithic repository code base, maybe you've got a really big project or a really big team, my first tip is please don't. It is so painful. It will not be worth your time. Just break it down. So you want to decide, preferably as a team, first of all, on how you're going to break that down. Do you break it down by technology or by the data source or by the data domain? For us, data source made sense, so that's what we broke it down by. You're then going to want to set up a naming convention for each repo. This means that if you say, for example, you broke it down by source, maybe you're going to call it by the source, each repo like that. It means that then if people are coming to the project new and they're trying to find a piece of code, they're going to be able to find it. As well as that, making a common structure within each repo. So we would always have scripts, tests, infrastructure, and a README. And across every repo, you will always find those. So again, as a developer, it just means that it's much more familiar. You come to a repo and you know exactly where you're looking for your code that you're looking for. Then these last two are kind of, again, similar vein. You want templates for your CI and CD. And we use infrastructure as code because we're all AWS cloud-based. So following a common pattern for your .yaml files. And again, as I've just said, that developer kind of being able to be familiar with the code, it will be a lot more familiar if all of these things follow the same pattern. Overall, consistency is key. Design a pattern, follow it as a team, and it will make it much easier. The next thing is tips for understanding APIs as a data engineer or analyst. Now, if anyone is like an API engineer in here, I'm sorry, because this is going to be me really brutalizing and making it very high level. But this is what I had to understand, because as a data analyst, we had always been given data by clients, and we had manipulated that data and analyzed it and aggregated it, and then we'd put it back into a graph and given it back to them. And that was kind of the whole life cycle of the data. But when I came in as a data engineer, we suddenly had data in a database, and there was an app, and I was like, how is our data coming from the database and going to the app? And this is where an API comes in. It's kind of that relationship between those two things. So 2 important things to know. First thing is what an API is at a high level, and a way that it can be described is an API is the handshake between the data you need and the software that you use. The other thing to understand is how many tiers your API architecture is and who owns what. So in our company, we have a 3-tier architecture, which I think is quite a common kind of setup. What that means is that we own the system layer as a data team. We have the APIs which go from our database out. The experience layer is owned by the experience apps, so they have their APIs which go from their experience apps out. And then the process layer is like an integration layer, which means that it puts those two things together. It builds the bridge between those two things. So the reason that you're going to want to know that is what we had a lot of was people coming to us and saying, oh my God, this is broken, like you've broken it. But sometimes we hadn't, and you want to know so that you can go back and say, it's actually not our fault. Not to be defensive, sometimes it was our fault. So if a consumer is getting an unexpected response, the first thing you're going to want to do is ask for a correlation ID. And think of this like a Royal Mail tracking number. If you type in your tracking number in Royal Mail, you can see all the different depots that it's gone through, where it started and where it finished. So what you can do with a correlation ID, use a monitoring tool. We use Splunk or Dynatrace to be able to search the correlation ID. And this will show you how the request is being translated through the layers. So what it came in as, and then when it comes down to your system layer, actually what it looks like. You can then use that request body to hit your API in Postman. So what I would do is then take that out, hit it, and see if I'm getting the expected response that I thought I was going to get. And if I'm getting the expected response, I can then go back to the consumer and say, actually, it's not our fault, which is always the preferred response. But a lot of the time it is your fault as well, so then you can go and investigate that. But what we found is that we were getting quite a lot of feedback, and we were going away and trying to analyze every single thing. And actually, if you follow these 5 steps, it'll make it a lot quicker as to which ones are actually worth investigating and which ones aren't. And finally, the tips for a great migration. The ducks are back. So first thing is that communication is key in flight. I think that we would have had a lot less tensions if we had realized that anything we changed needed to be communicated. Even if we thought it was really small, even if we thought it was definitely positive, you have to communicate it. The next thing is learn from those on the ground. This is something that we didn't do at the start of the migration. At the start, we tried to test every possibility, right? So because we were migrating, we were like, is every single attribute for claims, all 100 attributes, exactly the same after for 75 million records? That is so difficult to do. What we should have done, which is what we did towards the end of the migration, was go to our consumers and say, what data do you use? What do you care about? What do we need to be testing? And that would have made it a much, much quicker process. It's a tech conference, so I've got to mention AI. I think that, I've put this in, automate time-consuming tasks with AI, and I think this would have been helpful for us when we were trying to understand what the code was doing right at the start when we didn't have a clue. Now, the only flip side of that is because we went through and actually worked that out ourselves and went through the pain of that, I think that we understand it at a much deeper level. So I think that if we wanted to be quicker, we could have done this, but also I think it was, okay that we went the other way and actually got in depth ourselves. And lastly, strengthen your wings for the future. We started this project in May 23, I'm going to say. So it's nearly been 2 years. It's been a long time. And I think that if we could have lifted and shifted, that would have been great. It would have been way quicker. But actually, in terms of for the future, we now have a much more stable platform. We have much more stable code. And actually, as developers, we have a much better skill set and understanding of technology. So I think that in terms of for the future, we've definitely strengthened our wings there. So thank you so much for listening. I think I have 20 seconds left. So if anyone has a very quick question, please fire away.
Yeah, thank you. Are there questions? Oh, brilliant. On that side.
Oh, yeah.
Hello.
Can you go back to the slide just before the bench pressing doc? The first bench pressing? That's the second one. No, the one before, the next one.
Oh, the actual slide?
Yeah, no, the one, yeah, so here.
Yep.
You were talking about taking the request bodies from inbound APIs that consumers had problems with. How did you ensure that the data was anonymous?
What do you mean by ensure the data's anonymous?
Well, you've got the request body.
So we've got the request body from an experience app. So if someone is searching for their policy number, then how that trickles down to us might be that it's searching for their, insured ID. And we would then search for that insured ID and check that that's not causing any problems on our API. In terms of things like names and all of our proprietary information, that is all tokenized, so we can't see that. But yeah, in terms of IDs, sorry, that's probably what you're asking. So in terms of all of our IDs, like our accounts IDs and our insured IDs and our policy numbers, we can see those, but we can't see any information about kind of names and addresses and things.
Any others? Oh, yeah, sorry. It's a really bright light in my defense.
So for your single source of truth, did you consider traditional RDS systems led by business ontologies? Or was it we have Dynamo key value pair kind of stuff, so let's migrate to DocumentDB where it's key value pair stuff? And as well as that, for the analytical side of things, do you think RDS systems maybe like Redshift or something like that could help with the analytical side of things for even data science or in the future?
Yeah, so that's a great question, thank you. So when the data comes in through the pipelines, they first of all go to a data lake, and then they come into us. And the data lake is in Snowflake. So that's more of a kind of SQL queryable database. For us, yeah, we went for DocumentDB because it's for JSON-based workloads. We did think about Graph and about Neptune, which I think is the AWS offering for Graph. To be honest, we didn't have the skill set. And at the start, we thought this was going to be quite a lift and shift. So we were like, oh, we'll go with the thing which is the most similar. And actually, it's interesting because since we've spoken about it, we have, there could be another migration. It could be that Graph actually ends up being the right way. But, in this iteration, it wasn't. That's why.
Thank you. One more if anyone has it. If not, I'll ask. Is the duck just called Aflac, or does the duck have a separate name?
I think it's called the Aflac duck.
Okay. That's what I needed to know.
Yeah.
So thank you very much, Izzy.
No problem. Thank you.